Hello everybody, this is Mr. Kestel. I am making a short video, hopefully short, video about the electrical system inside most planes. So this is going to go through the information covered on this worksheet here. I am planning on doing it in sort of a different order than what's on this worksheet, as I will explain. Okay, so I'm going to start by explaining kind of electricity briefly here. I will put a timestamp down in the description for the next part of the video. So starting to look at the components. So if you want to skip past this explanation, you're more than welcome to. An electrical system is a bit like a water system. In water systems, you have some sort of pump that pushes water through a series of pipes. And an electrical system is something similar. So you have a battery which pushes electrical current, through what we call a circuit. So in a water line, if you have a big, wide pipe, that means there's very little resistance. A lot of water can go through. And if you have a skinny pipe, then not very much water can get through. There's a lot of resistance. Similarly, there can be parts of an electric circuit that causes a lot of resistance. A light bulb, for example, has a lot of resistance to electric flow because there's only a tiny little wire going across inside of a light bulb. So a constricted pipe or resistance is a load, something that causes resistance. And so a motor or a light bulb can be those things. So you've got two different things that you measure inside with electricity. The first thing is called voltage, which is kind of like measuring the pressure of a system. So you can think of it like if you're talking about water, if you've got high pressure and like a lot of water coming out, like a fire hose that firefighters use to put out fires, that would be kind of like having high voltage. And something like a sink barely turned on would be kind of like low voltage, not much pressure. And that is measured in volts. Now you also have current, which is the amount of electricity flowing through a system. So it's kind of like how much water goes through, how fast does it go? One way to think about this is that if you have let's say you're at a drinking fountain, and you've got some water coming out, but if you put your thumb and cover most of the drinking fountain, you're going to notice that the water seems to come out a lot faster. So it's the same amount of water. There's the same amount of pressure in the pipes, but the current, the water shoots out a lot faster because of that resistance that your thumb is putting on there. So if you, inside of an electrical system, you've got a combination of the pressure to push electricity through the system and the current. So going back to that water fountain, you don't have more water coming out. You just have the same amount of water coming out. It's going at a faster speed. So that's sort of like saying the voltage is the same, but the current is higher. So there's all sorts of different things that this can apply to that we're not going to get into in this. So something different about electricity is that it's got to have a path to follow, and that path has to make a circle. That's what we call a circuit, A circuit is another name, like basically a circle. So it has to follow a path to have the electrons flowing through the circuit. So you've got a power source, for instance, a battery, and the electrons are going to flow through the circuit. Now, if you have a switch, which basically opens, or it can be open or it can be closed, that can turn on a circuit or turn off a circuit. So, for instance, when you turn a light switch on in your room, that closes a circuit, so the electricity can flow to the light bulb. So on the left here, the switch is open, so the pathway is broken and electricity cannot flow. And on the right here, the switch is closed, so the electricity can flow.
Okay, so I just want to reiterate, I am going to be going through this worksheet in sort of a different order than what is presented. I'm going to start by doing some of these components here, talking about what they do, and then going back up to this diagram and kind of explaining where they fit into things. So this stuff on the side here, the word bank, that's probably actually going to be toward the end of the explanation here. So, and then the last would be what comes down here at number 3. So I just wanted to reiterate that. Okay, so the first component we're going to look at is the battery. Different aircraft will have different size batteries, but the primary purpose of the battery is to get the engine started. So battery stores energy, and then you use the battery to get the engine started. The next component is the starter. The starter is powered by the battery. The starter is a component that gets the engine started, turns the engine. So this requires a whole lot of load or electrical current from the battery. So the battery's main purpose is to get the starter turned and get that motor going. So it's very powerful. It's small but very powerful. It uses a lot of current to get the actual engine to start turning and get going. Okay, the next component is the battery starter contactor. This is part of the ignition switch that sends power from the battery to the actual starter. You don't want to have the battery hooked directly to the starter because you need a way to control when is the battery going to send electricity to the starter. So that's what this component does. It also allows for less heavy-duty wiring because there's so much current going from the battery to the starter to get the engine going. This is a device to kind of help keep it safer and give control over when are you going to send that current to the starter. Okay, the next component is the alternator. The alternator is a device that is attached to the motor that spins a magnet inside of the device. So the belt turns and it turns a magnet inside of the device, and that creates an electrical current inside of the wires around the magnet. This is used to create and produce the electricity that most of the plane uses. It also gives it recharges the battery. So I've got a little video here that I'm going to show you. It kind of explains the same things again.
Similar to a car, the alternator is driven by the engine through an alternator belt, which generates electricity for the entire system. The alternator is the primary means of powering the electrical system during normal operations with the engine running. Not only does the alternator provide power to the electrical system, it also charges the battery. The battery is mainly used to start the engine or to power the equipment while the engine is not running.
Okay, our next component is the alternator control unit. This is a device that determines how much how much power the alternator produces. You don't want the alternator to overload or provide too much power. So this controls the alternator and how much electrical current is going to be produced by the alternator itself. And that's based on the needs of the system. So if you've got more electronics turned on inside the plane, then the alternator control unit is going to have the alternator make more electrical current. And if you don't need as much, then it'll draw that back. So next up is the master switch. The master switch is what controls all the electrical power for the airplane and starts all of the systems running. So this is like this big red button right here, master. Alright, so to go to this diagram here, you should already recognize many of the components that we've talked about. We've got our battery and the battery contactor. We've got the alternator and the alternator control unit. We've got an ignition switch with the starter, contactor, and the starter. So the battery is connected to the battery contactor. So this goes to the master switch. So when you turn on the master switch, that's going to supply power from the battery to the ignition switch. When you turn on the ignition switch, that sends electricity to the starter contactor, which is part of the ignition switch, and gives electricity to the starter. So then the starter turns the engine. So now you've got the engine running, and usually this switch is turned off again, the ignition switch, because you do not want the starter to get messed up when the engine is running. So now that the engine is running, that is going to turn, as you saw in that little video, the alternator belt and turn the alternator. So you've got electricity now being produced by the alternator, and you don't need the battery anymore. The battery is not used to power everything. So the alternator current control unit controls how much electricity the alternator produces. So and the master switch is what kind of connects everything together, turns it on so it's ready to go. Now we've got the ammeter and the load meter. So the ammeter is a gauge that tells if the system, the electrical system, is basically charging or discharging or kind of in a neutral place. So this will help a pilot decide if her plane has enough electrical power. So you don't want to be constantly discharging or losing electricity in your system and use up all the charge in your battery. And so this kind of helps, the ammeter helps to tell the pilot how much her plane is, how much electrical current, not how much she's using, but what the status of it is. If her plane is if the electrical system is charging or discharging. The other part of this diagram is the load meter, which tells how much load is on the electrical system in the plane. So this again is the more electrical systems are on, the bigger the load is going to be on the electrical system. So if you're alternator is producing enough current and is capable of running everything, then you're doing fine. But if there's something wrong with the system and say it's discharging, then maybe you want to drop some electrical systems so that not as much electricity is being used. So the load meter will kind of help a pilot gauge that. So if there's something wrong with the electrical system, for some reason the alternator is not working properly, this can help her figure out how much electrical systems are affecting the everything as a whole, so she can get back into a place where she has enough electricity to run all of her systems. Now, to help keep the electrical system of an airplane safe, we have these devices called circuit breakers. So a circuit breaker is a little device that is hooked into the electrical circuit, and it pops or breaks the circuit if too much current is passing through that the breaker. So if you've got a system, let's say your radio in communication radio inside the plane, you don't want too much electricity going into that radio, otherwise it's going to melt, fry, maybe even cause a fire in the radio, and fires in planes are not good. So a circuit breaker will automatically pop and break the circuit if there's too much current passing through it. You end up with a whole big old panel full of different circuit breakers, and depending on the circuit and the individual components, they may be more sensitive or less sensitive to how much current is passing through. But all of these little things are circuit breakers that will prevent too much current to going to that particular device.
Circuit breakers are usually grouped together in the cockpit by the bus they are located on. Not the bus that brings you to school, but an electrical bus. An electrical bus is like a power strip. You can plug multiple things into a strip, and if you turn that strip off, everything plugged into that strip will not be powered. In an electrical system, the same remains true. The components of an electrical system are usually divided into multiple buses. For example, there may be a main bus and an avionics bus. On the main bus, main equipment such as lights are powered, and on the avionics bus, most of the instruments and equipment to run those instruments are powered.
All right, I hope you enjoyed that extra little bit in there. So it kind of already explained what the primary and avionics bus is. And don't worry about this picture right here as far as understanding everything that's on it. But the point is that there's two different you can kind of think of them as like power strips. There's two different power strips or buses that kind of give out power to different systems inside the plane. So you have the primary and you have the avionics. The primary is just described as everything but besides the avionics. So let's talk about what the avionics is. This is the equipment that is used for instance navigation and communications. This are the sensitive items that are important for making sure the plane is able to talk to people and get to where it needs to get to. All right, so now the last is the avionics master switch, which in this picture I showed earlier, we had the master switch, and then we've got the avionics switch. So the avionics switch turns on all of the systems for navigation and communications and that sort of thing. It's kind of basically it's like an extra protection against problems with the electrical systems. So especially when you're starting the plane, you're starting the battery, the starter. If something's not connected properly, you don't want a whole bunch of electricity just willy-nilly going through your radio and your GPS and autopilot. So that's why they have an extra switch in there to protect those systems. And going back to this diagram, we've looked at all the stuff over here on the left, from Ammeter on over to the left. And these all are part of the primary bus. Then the avionics comes off of that, so you've got a switch for that all by itself, and that controls, that controls navigation radio, your GPS, your transponder, which is basically a device that when it receives a radio signal, it sends one back out. So that kind of helps to locate where the airplane is at for ground control. Your comm radio, that's communications. And then your autopilot, those are all, and your avionics fan. The avionics fan basically is just a fan to keep, literally a fan to cool avionics equipment. So you don't need that turn on if you're not using the avionics equipment. So all of those things are part of the avionics bus. So everything else, for instance, your fuel quality indicators or quantity indicator, landing light, strobe light, pilot heat, oil gauge, and wing flap system, those are all part of your primary bus and are separate from the avionics bus.
All right, so the last part of this assignment is to draw a basic electrical circuit that incorporates a battery, a master switch that controls the devices found on the primary bus, an avionics switch that controls the device on the avionics bus, and that's it. So I don't particularly care how you go about doing that, but it will probably, it's not going to look exactly like this because this does not show anything coming back to the battery and the alternator. Just give this your best try, number 3, and that'll be totally fine. If you're not able to, if you want to, you can draw this out and then take a picture of that, or use, if you've got some sort of, like I have Paint, Microsoft Paint on this computer, so that's what I would probably use. But just give us your best shot. I hope you enjoyed the video and have a wonderful day full of laughter and joy.